soon as they start out something. I am Owen Williams, yes. You read it? No. Must be another Owen Williams.
That's so funny.
There's like 10 there's 10 people left my name. Not Evans. I got a call from the drum woman at like 2 a.m. They're waiting me for like not calling her after going on some date. And I was like, lady, I'm gay. I knew it! Oh, that was hilarious.
All right, well, let's get started. My name is Owen Williams. I'm a user interface designer, application developer, and framework designer. I mostly work in JavaScript doing front-end stuff. I was doing Ajax before Ajax was a thing. I've been very interested in a very long time in how to make computing a more democratic process, meaning opening up to more people. When I was about 16, when the Mac was fairly new, a program came out called HyperCard, and its programming language was English, and that has really informed how I think about programming. And what we're going to talk about is kind of a result of that. So it's basically been a 20-year quest to kind of bring some principles that were around back in the late 80s, mid-90s, up into forward into that. So can I get a sense of who's here? So who here is a developer or a programmer? Okay. Who's here is a designer? Okay. Who here is into like, here because you're into cognition or that kind of stuff? Anybody into like machine learning? Okay. The reason this is an algorithmic approach is because it's specifically not a machine learning approach, just to explain where that came from. And the conversational programming is, again, the idea that instead of it being in, like, when people ask me what I do, my job is to teach computers to talk to people, not the other way around. And so it's a conversation with a computer which would start with possibly talking, but also possibly typing, but having it be a dialogue where it's kind of back and forth. Okay, so the vision for this system I've been imagining for the past 20 years is a layperson's programming environment. The end goal would be that a layperson could write an app. Or if they can't maybe write an app from scratch, is maybe they could take an app that was existing in open source state, written in the system, and then customize it for their own use. And examples of things that people might want to do: games, Internet of Things, home automation. Again, thinking about using an English-like syntax to put your components together for your home versus having to learn an artificial computer language. Managing your personal data, home finances. My mother was a shell collector, and she had a little file maker program that she made for her shell collection. That would be a perfect example of this. Like, there's no way somebody can afford to make that and sell that product, but maybe you could take a collection thing and really customize it and get it to be exactly what you want. And then finally, in the more commercial vein, the idea that a IT department who's creating software for a company would be able to create it using an English-like syntax so that the business owners could, the business stakeholders could actually go in and look at the logic and actually understand what's going on and feed into that process. So parts to kind of figure out. The idea is that you're using a drag and drop application to assemble your pages, to create your components, to throw your components together. Then you have an English-like language for the app logic. And again, the goal is to translate human language into a computer language. Right now we're starting with English. There's no reason this could not apply to any language, any computer language. And we'll talk about that a little bit more. And right now it compiles into JavaScript because that's mostly what I work in. But again, there's no reason that this is limited to JavaScript at all. A couple other parts I'm going to concentrate on this second one, the English of the app logic. The layperson-friendly data model, that's a big topic. But I'm kind of talking about the parsing, and then there's the whole concept of what is the meaning of what you're trying to do. So I'm trying to understand what the words are, and then what the words should do is another question, which I'm not really going to get into too much tonight, although I'd love to have a discussion about that afterwards. And then the final piece that I see is having a marketplace for apps and components and language extensions that people could download. Ideally, a bunch of this would be open source, some maybe prepared. So you could say, oh, I want time zone support, and then you grab this library, and all of a sudden you've got this new capability of not just a new API, but actually new language structures that you can use within your application. So, if I'm going too fast, please stop me. Okay, so why would you want to program in English? So I would assert that even if a layperson couldn't write a program immediately, if the program was written in grammatical English, they would be able to read it and understand it. And I think that's a really big thing. That people really don't want to do math. Curly braces and semicolons and all that kind of crap in our computer languages just turn people off so quickly. And the concept of, oh, it's just English leads to experimentation. Like you're looking at something and it says this is that. You're like, oh no, this is not that. Your brain immediately can go into extending it and working with it. There's the concept of literate programming. Is that who's familiar with that? So literate programming kind of turns the idea of programming on its head, where traditional programming is a bunch of code with little comments in the middle of it. And literate programming is a bunch of comments with little bits of code. And so actually having the document that is your program actually tell a story, and then you just insert the little bits of dynamic code that you need. So the idea of kind of taking the specs, writing the specs out in English, and then actually morphing that into running code, it's kind of that's what I want to do. Makes the code self-documenting, and I note that maintenance and extension of code is 90% of the time we spend with code. So taking it and making it in as high level language as possible, it makes it more likely that you'll be able to do more with it, to understand it. And then what I'm seeing as I'm looking at the current landscape, especially in the front end of the web, is that things are moving toward functional programming and trends that really make things less accessible for a layperson. They're getting more mathematical. And the advantage is they're more mathematically provably correct, but that again is knocking more people out of the equation. Less people will be able to use the systems. And then finally, talking interfaces are coming. We're already talking to our phones. I would love to be able to program on my iPad or my iPhone, without typing constantly, and being able to, kind of interact, like to listen to the code. Curly braces just aren't going to cut. Nobody wants to listen to that. So. Okay. I would rather wait at the end if you don't like it. If there's something that's completely unclear, then feel free to stop. Okay, so inspiration, HyperCard, and then there's some derivatives, supercards, one, and I'll talk about those for a minute. Python, the thing I like about Python is they did go for fairly English-like syntax in many ways. They took the curly braces out, for example, in indentation. Inform is a system for interactive fiction, so like Zork, if you guys remember that back in the day. And they have a really great English language parser as part of it, where you're describing these rooms and these things in the rooms, and when I touch this thing happens. They've done a really great job in this very small domain of making a very English-like system. And I highly recommend if you're interested in this and taking a look at that. The concept of literate programming I mentioned, and then just in general the work of Brett Victor. Who here is familiar with Brett Victor? He's really one of the most innovative thinkers in terms of humanizing interface. He does a lot of stuff visually. He's not doing as much stuff with kind of textual representation. But I find his work really inspirational, so I highly encourage you to take his work. Okay, so HyperCard in particular, it was the first non-programmer programming environment. It came out in 1986, like 2 years after the Mac came out. And before the web, it was really the most widely used programming environment in the world. And it's had a very simple mental model. So this is back when the Mac screen was about this big. And so the model was that you had a stack of index cards, a stack of 3x5 index cards, and you were flipping through those on the screen. And it just made sense, Another significant thing is it had this English-like syntax, which is somewhat the model of some of what I'm doing here. It had an inherent database. It actually automatically saved. It was the first time something automatically saved, which was, again, it's like right now we're like, oh, that's why we didn't do that. First, that was so new at the time. And then it allowed this meta-programming, so you could actually create a HyperCard stack or an app that would create another stack using its own language. And so that meta-programming capability really kind of affected my brain, and that's how I think about solving problems now. Limitations, it was Mac only. There was no concept of a network with it. Again, this is before, this is when dial-up was still a new thing. The data format was something you could not work with, so you just had this big blob of data that, if it got corrupted, which it would occasionally, then you're just screwed. The whole thing was gone. There was no source control, none of that kind of stuff. A very limited set of data objects, and it was difficult for someone who was not a programmer to extend it to. So. So for this language, this mythical language which I'm constructing, here's some of the principles I'm trying to stick to. The phrases they all have to be grammatical English, no Yoda speak, so don't contort the syntax to make it easier to parse. Embracing ambiguity. So part of that is providing multiple ways to say the same thing, so you can use whatever flavor of the expression makes sense at the moment. And also, because we're trying to parse English, there are going to be ambiguous statements where the same statement can be parsed in two different ways. So taking that into account and then building a system to figure out a way to have the user go into a dialogue to say, oh, this is actually the way I want that to be, and I remember that for the future. Most parsing systems make you design the language so there's no possibility of ambiguity. And so they're so limited that's why we stunted computer languages like that now. Make as much of the definition of the language as possible declarative. I'm saying it's actually okay to use basic math symbols like plus and equals and stuff like that. Stuff that an early high school student would understand. And then using JSX. How many people are familiar with JSX and React? So React is a framework for doing front-end applications, which was created by Facebook, and it's taking the JavaScript world really by storm. And they have this concept of embedding little snippets of HTML, XML, whatever you want to call it, right in the middle of your code. And it makes it very clear that, like, here I'm doing logic, oh, and here's an output node. Here I'm doing logic, here's an output that's going on the screen. So embracing that and trying to extend that to build it in as part of the fundamentals of the language. Okay, so here's just an example of a type that's written in this language. So, let's see. Okay. So we're declaring a bunch of properties. Some of the properties are just declared as a type. Some are, like this property suit is declared as one of those things, and the language would enforce that you can only set it to one of those things. The color is defined as a derived value, and you can see, like, even if somebody couldn't write that initially, they should be able to read that and understand exactly what's going on. And if the logic was wrong and it said, oh, if it's one of clubs or hearts, somebody who didn't know programming would be able to read that and understand what they wanted to change, how to change it. Okay. And then we have, these are methods or functions or actions. And these are, this is an example, this is JSX. So this is actually an expression that would be used to render nodes in a web browser to create this interface. And something really interesting to see here is that this type definition to turn card face up is actually used within the same file. So within this, the definition of this class, the user who's writing this within the language itself is extending the language and adding new semantic structures, new sentence forms to the language. Does that make sense? It's actually kind of a really interesting problem. You have to parse the file before you parse the file. So, I'm calling this version 2. It's definitely still embryonic, but it's getting interesting. Parser is currently written in JavaScript. And the dynamic nature of this language means that typical parsing programs which typical programs we use to write a parser are not appropriate. One of the main reasons is the ambiguity. Typical parsers do not allow you to have an ambiguous language, they just bar it completely. Also, the language itself needs to be dynamic, where when I'm importing a new type, that's actually adding new phrases and new definitions into the language that can then be used by subsequent classes. And all of these systems are only designed for a very tightly constrained thing that cannot then be extended. And again, the parser implementation is not important here. It's really this is more an experiment in, like, how can we solve this problem of talking to the computer in our language rather than talking to its language. So, again, I'm really happy to talk about the technical details, but the important thing is the concepts of so there's 3 basic concepts in this system. The tokenizer splits raw human text up into tokens, and tokens are little bytes of semantic meaning, so like a number or a literal keyword or a block of that JSX structure that we were talking about, or a comment. And then the parser takes a string of text and applies a set of rules to them, and then it outputs a syntax tree, which then represents how it understands that body of text to be structured. And then that then will get translated into JavaScript or whatever language that you're dealing with. And then the rules themselves are little fragments of syntax which are ultimately combined into statements, which are then combined into your program, into your type. And we'll go into the rules a lot more. So in order to make this process really quick, I declared this rules syntax. If you're familiar with regular expressions, who here is familiar with regular expressions? Okay, great. So just think regular expressions, and when you see a curly brace, that means do a subrule. Okay. So the target for this is a programmer, and the core rules in the system are all written in this rule syntax. I need a name for this concept, so if anybody comes up with a better name than rule syntax, I would love to hear it. That would stretch my brain. So a couple examples. So if, then it's going to match some kind of expression, then, and it's going to execute some kind of statement. Or in this case, empty or clear, either one of those would work. And then a list. So empty the list, meaning take all the data out of it. Or here, define type, and then you're specifying the name of the type as a supertype. And I'll get into the last one in much more detail here. So if that's our expression, our rule syntax expression, define, type, and as are all literal keywords. So it's just going to match that literal string. Type is a subrule where it's saying go to the list of rules and then match the type rule. In this case, that happens to be a regular expression itself. But it could be any number of things. You can actually name subrules. So notice we have type here and then also here. So in the output, one will be called type and one will be called supertype. The expression with the bar there, a or n, is an alternative. So either keyword would work in this case. And if you define two rules with the same name, like if I was to define type twice, that would then become an alternative, where it would actually automatically match either node that's acceptable for that rule. And then the question mark at the end of this marks the group as optional, that can be present or not, and just like regular expressions, question mark means 0 1 times, star means 0 or as many 0 to n times, and the plus means 1 or n times. So the plus would be, you have to have 1 and then you can have as many as you want. Is this making sense? So nodding, okay, good. Let's see. Oh, that last time. So that rule would match the text define type card or define type employee as a person. And the syntax tree you would get is this, basically, where define type, a type, and super type, the blank person here. So then you would then write a tiny bit of code here, which then takes those variables from that you got as input and then outputs JavaScript. Or again, it could be Swift, it could be Java, it could be Haskell, it could be anything. Let's see. Okay, and something I've noticed recently and am working on very soon is if you look at the output from, if this is the input line, the output line is actually very similar. And so I'm going to be working on a way that you can declaratively say, oh, here's the output without actually having to write code for the output as well. And again, the idea is some of these regular expressions to be able to jump in and just try to do stuff right away. And again, trying to keep everything as declarative as possible. Right? Let's make the machine do as much work as we can. So, okay, these are the different types of rules. I'm not going to go into this, but if people are interested at the end, we can go over it. Okay, so a unique feature of the system, as far as I've seen, is that we define the parser in layers. So there's like the core layers, and then you would have like layers that you get from the marketplace or that you have a programmer write, and those may be adding new concepts. And then you might have app-specific layers for your application. And so basically each file is a layer, and that way if you have, essentially it allows you to extend the language without a top-level layer polluting a lower-level layer. So if you have a library that's dependent on two concepts, and you introduce something else here, the library wouldn't even see that. This is about it.
That part, that was a little bit confusing.
Okay.
So if you have a top layer, right?
So let's say we've got a core layer which is defining list-like functionality.
Right.
And then we have another layer that's dependent on that, right? And let's say I have my own, like an application-specific layer that maybe also is dependent on the list-like layer. This piece of core functionality won't actually see my layer, my thing over here. It's a way of
So you're
keeping
just looking at dependencies basically. But so I guess what I'm wondering is like if you have one layer that depends on another layer, right? But their English structure is identical, but they have different functionalities. Then there's like a conflict here.
Then we get,
Maybe
we're about to
that's
get into
a little
ambiguity.
unrelated, so I don't want to jump ahead of myself.
Okay, we're about to get into ambiguity in a second. So that's actually one case where the layering is actually interesting, because you could say, oh, I've got an application-specific way of interpreting this versus a core way of interpreting this. So I'm going to favor the application-specific way, although there should be a way for the programmer to go and say, oh, actually, no, I want this one. Right? And I'll get into the possible differences. The language itself is just composed of these rule strings.
So this is kind of like you're talking about how the parser.
How the parser actually works, yes. Yeah. Okay, but again, the idea that the important takeaway here is that the language is flexible and the language is meant to be extended, and again, we have to do whatever we need, right? Rather than just saying, you can't make something ambiguous. Let's say, okay, well, how can we deal with it? Okay, I'm not going to get into this too much. Again, these are just some examples if we wanted to dive deeper into what are. These are just some default rules that are provided by the system, basically, and there's where we got into in a sense. Okay, so talking about JSX a little bit. So when you hear JSX, just think XML plus data types and embedded in another program. That's really the high-level way I think about it. And the idea, again, is that we're using this to express components, visual components that we can kind of create on the fly. So it's like we're making our own HTML tags up and we're sticking it right in the middle of our code. And again, this is something that Facebook has really pioneered, and it's working really well, and people are really embracing it like big ways. So why JSX? HTML has proven a relatively easy format to teach. I was able to make a little website for my mother in HTML, and she was actually hacking it, by herself after 3 hours of instruction for several years. So in practice, we're actually going to use a drag and drop editor to create these components and to put our pages together and stuff like that. But then what I want is I want the format that that's stored in to be human readable, so that you can actually go in, and if it's faster to you go and hack the XML directly, go ahead and do that. But for most people, it's probably better to do the drag and drop piece. And also within the code, it distinguishes the output from the internal manipulation of data. So when you see a JSX block, you know that this is going to be presented to you, which to me is important. So, and one of the things I'll talk about is I'm looking to unify. Right now, to do web programming, you have to know HTML, CSS, and JavaScript, and they each have their own very different syntax and methodology for working. So I'm trying to figure out a way to kind of unify those. So here's an example of a possibility. And again, this is part that's probably the least thought through of everything we're talking about today. So I might, using my drag and drop editor, create this. So if I'm creating a solitaire game, the foundations are where the aces, where you would move the cards up to. So I create these 3 piles, and pile is something I defined somewhere else, or maybe gotten from the marketplace, from that library. So this is how they're represented within the page. And then here's our CSS. So we say, when you see a pile, then add these properties to it. When you see a pile with type equals foundation, and notice that this syntax is the same syntax as up there, as opposed to CSS, which has a completely different syntax for no apparent reason in my mind. Then this is adding additional rules. So again, it's trying to map these concepts into the same kind of semantic namespace. Okay, so what's working now? We can tokenize natural language and these JSX expressions. We can use the rule syntax to create arbitrary parsing rules of various flavors. We can parse individual phrases and statements and JSX blocks. We can parse blocks so it understands nesting, for example, for that method, for the class definition, where it's all of these things are part of that class definition. It understands indentation for nesting, like Python. We have the layered parser concept, and then translating, outputting JavaScript from the input, and then the unit tests. So I'll switch over real quick to show the. Okay. So this is just a test application, and this little gray button there. So it just compiled this code from the English into JavaScript. And this is actually semantic ES 2015, or actually ES 6, but and again, the actual text is certainly, the actual text that you're writing here is certainly improving, but the idea of having this easy way of declaratively saying, hey, when you see this, I want to output that, that's kind of interesting. And it's about half covered with unit tests. So a couple of tricky areas when you have rules that, when you have a rule that is calling itself. So if we say, as an expression, expression equals expression. Then we go to parse that and say, oh, well, I have the rule expression equals expression. And you keep calling that rule over and over and over again. Most language parsers don't allow you to do this kind of rule. I figured out a heuristic that I think is working in terms of how to stop that chain when it gets pathological. The other tricky bit is, what do we do if we have two possible interpretations of the same bit of text? As a simple example, if the text is the name is empty or the name is nothing, it could be parsed as the name is empty or the name is nothing, or it could be parsed as the name is empty or the name is nothing. Right. So how does the parser know which is the right one? Right. How does it know which of those? So currently I've got a very simplistic rule in there. This is an area where I'm looking for ideas and experimenting. You can add parentheses explicitly. So if you parenthesize this bit and then this bit, it would get that, which we all know is the right one, or the one that we would want it to get. What I'm thinking of as an interface is it could pop up a UI where it would show them the sentence tree structure, or the multiple sentence tree structures, and say, which one did you want, basically. And so the trick would be getting that so that an end user would be able to see that kind of sentence structure and not get freaked out, right? And then somehow we have to remember that choice in the text so that we'll make the same choice again later for the parse file. So, okay, so future directions, short-term stuff. Declaratively specify the translation rules, as I mentioned before. So again, just the idea of writing as little code as possible. Pre-process the files to extend the language. So that was when you said to turn card over, and you could use that within the same file and then subsequent files. Where it's actually the end user being able to modify the structure of the language. The sentence diagramming language I just mentioned. Right now, it's basically kind of it's in a hacker tool kind of stage where I can test things in the browser and that interface where you can paste text in there, to see the translation. So actually getting into a service where you would be able to use it in a JavaScript library to say, here's some text, and actually getting backlinking code. We're pretty close to that, but it's not quite there. And then I would love to get a group together who's interested in discussing the syntax, like what should it be, should you have to say define type, or should you just be able to say type is blah, that kind of English thing. I'm very interested in that. And the nice thing again is because it's this declarative syntax, we don't necessarily have to have one right answer. Okay, and then longer term, I'm thinking this needs to hook up to a database paradigm. Again, the idea that you're building up a world by manipulating this kind of corpus of information, or this app world, and then acting on that with the language. So I would consider that adding meaning to the words that we've understood. Right? When I say this, what is it? What action is happening within the system? human languages other than English, that initial description of the rule syntax could be Spanish as easily. Outputting other computer languages, and then the basic the parser and tokenizer classes are about, I don't know, 4 files worth of code, so it's very easy to translate into Swift or into Java if other people were interested in using this. And again, ideally the rules would be able to translate between those different languages. Okay, so that's the presentation. Definitely open for questions. That's a link to the class. You can just download it and run it, MIT license. This is me, and I'm actively looking for people who are interested in using this in a project. I'm at a place where having some customers would actually really help me refine what needs to happen next. So if this is of interest to you and something you're doing, please do contact me, and I would love to work with you on this. Okay.
Hey.
Yes.
So Owen, I just want to make sure I understood exactly what the overall goal was, or is in your mind for you, is to, I think you're trying to create a sort of WYSIWYG editor to allow a person who is not familiar with a programming language like JavaScript in order to build an app, right? But there may be certain parts of that process where they will have to tell the computer to do something, and you are sort of gearing them towards a more natural English language. Is that kind of what you're envisioning?
That is, yes. And this was specifically about that English piece.
Okay.
I do have some stuff of that drag and drop piece worked out as well, but I just didn't want to put too much into it.
Okay.
Well, when I was in college, I mean, I'm a fine artist. I went to fine art school. I worked at Apple as a designer. Like, I'm no programmer at all, but like, I use HyperCard in college. I don't like programming, but I use HyperCard in college to build a game, like a little interactive like game. So I mean, I'm like your mom.
You're just like my mom.
So it's just like your mom. Yeah. So it's interesting. Yeah. To keep up. I wanted that. I'm basically climbing the user.
So, a quick question about, I guess, passing around context. Yes, like a lot of ambiguity happens from missing context or so forth. So I guess like that would be really interesting to. Do you have that in mind?
I do have that in mind. I have not. There's little stubs in where it says pass context in here, and I'm not doing anything with it. You actually need context in the parsing stage as well as in the translation stage, right? So you might right now there's an identifier type or an identifier rule, and there could be, say, a previously scoped identifier rule where if you're saying x equals y, you can define a new identifier, but if you're using it within the context of anything other than assignment, you would say, oh, you have to have a scoped identifier that's named within your context. So I've been kind of hand-waving that bit, and I'm about ready to tackle it. So if that's interesting to you, I'd love to talk to you about it.
So I wrote this article recently about Lego sorting. This guy built a Lego sorting machine where it's like this little like conveyor belt, and it automatically sends out one Lego at a time, and the machine will scan it through a camera, and it recognizes it and it sends it into the corresponding barrel. And originally what he was going to do was try and find all the Lego pieces and program it in there, but ultimately he realized that there were numerous, just tons and tons of different kinds of Lego pieces and so forth. And so what he did was he ended up training the machine on recognizing certain categories of Lego pieces. And then using machine learning, because trying to create that himself would have been, from his perspective, it would have been overwhelming, almost impossible. And so it was successful, right? Now he actually has this Lego sorting machine where he bought tons and tons, literally, metric tons of Legos and sorted them into barrels, right? Using just machine learning. So I think maybe you could think of it that way, potentially, where you have this conveyor belt of words in the English language, or other languages, potentially streaming in, and you want to be able to essentially apply it into containers of, well, these words go together over here, right? So maybe trying to create the parsing structure and so forth just by hand may be one solution to work alongside with machine learning.
I certainly think so. I'm not a machine learning guy, and so that's why, again, this is why it's an algorithmic approach. And I think there's definitely promise in that. The problem with that is you would need very clear inputs and outputs. So you have to create this large corpus of when they type this, they want that. And what I'm trying to do is get this rule syntax as close as possible to that, where you're essentially just the things that you're feeding it are as declarative as possible.
Maybe you could do sort of like crowdsource machine learning in a sense, where you say, okay, here's some JavaScript. Like if you could write this in English language, like what would that look like to you? And then you have 1,000 developers that write it in English, and then you feed that to the machine. I don't know. I'm not a machine learning expert.
Yeah.
It's just like
That's certainly a possible approach. Yeah. One thing I like about this is it's actually very traceable. That if you have a machine learning, like a neural network kind of thing, it's hard to know what input, why you got this output to this input, because the machine has done all that. Whereas this is actually very directly traceable. Again, this runs in real time within a browser. So, yes.
I want to add something that you were talking about. When I write a lot of code, and I actually spend a lot of time drawing pictures before I even sit down and try to write the code. So I end up with diagrams, again, like how different parts connect to each other. So at the end, each little segment is going to have just a little bit of code in it. And so, whereas language is kind of like linear, one thing, there's this other aspect of looking at to do this, which is more of the visual, two-dimensional, relational between things. And have you ever thought about?
I have actually. I had a little bit. I thought through like the idea of a kind of a movie. Like if I was wanting to get a project like this funded, I thought through a visual movie of how you could be talking to the computer, and it would be kind of defining the card, say your card name. And it's creating structures in 3D space to correspond to this, which would then translate into this language. So what I'm trying to do is get that language so that I can kind of build both pieces. If that makes sense. And I'd be happy to share that with you. If you want anything in your email, I'll share you that. That's good with you. It's actually something I'd like to look at.
What is it? There's like there's something that keeps the Apple. I remember seeing like little blocks where you're like connecting. It's kind of like drawing diagrams where you're taking these pieces and you're connecting them with lines and saying this goes to this. And I forget what you have that program.
Automator.
Was it?
Automator.
Automator. Well, Automator is more linear. What I'm thinking of. What's that?
Auto layout?
Maybe.
Sport composer.
Yes, that's it. That's the one. Yes. Thank you.
Computer programming too.
Yeah. It's like these little blocks that represent specific things.
Yeah, that's called,
I
it's called
love
a
all
noodle
those things,
diagram.
and what I want is that the output of those is English,
Noodle diagram.
or
Well,
English
I'm also
instruction.
thinking about from the perspective of starting to figure out how to do a problem. And it's just breaking it down into, and also the program usually grow. I mean, things are not just slow. And then you look at someone else's work, which is like pages and pages, but it doesn't matter what language it is. It's like you don't know what it means. It's just this one big long thing. It'd be great if you could, for me, to like put in something like a visual mapping image that would like, simplify it.
Stay tuned for next year's talk. Actually, just one thing I wanted to say about my goal right now is this kind of drag and drop environment. I think this parsing system is actually not tied at all into that. So, which is part of the reason I wanted to talk about it independently. This is just a generic way of creating parsers, right? Translators. Yes, sir.
Are there any like sample programs that I could look at, like examples?
The
I showed one, but on the Git repo.
I will post those in the next couple days.
I guess I have one more question.
Yes.
Did you have any intention of like, I noticed you mixed in some HTML and then like pseudo CSS in there. Is there any intention to like merge that into your own English language syntax so you can structure that? Because it seems, I mean, it's kind of awkward honestly having the HTML and CSS, in where everything else kind of is just like running with English, right?
I actually see
You're not requiring that though. You're just providing a way for people to
again,
know.
the idea is that you would not be coding that stuff directly. You'd be coding that through a visual interface, and the artifact would remain as that structure. And again, I'm choosing HTML because A, it works really well for my brain, correctly. And B, it's proven fairly easy to teach people. It's a way of providing the structure with attributes and stuff like that that people can kind of draw. Not necessarily intuitively, but usefully.
Makes sense. Same thing with time. All right.
That's it.
So, I was looking at your code. To me, I mean, I teach kids programming, and it still seems kind of like code that I have learned the language. Well, I'm just wondering what would it take to make it more easier? Like, just like, one sentence, you tell it what to do, and it just does it. Like, what is the technical challenges that are preventing to make programming like even super easy? Like, you say build the website, and it just kind of does the thing. You know what I mean?
Knowing what they mean when you say build a website, I mean.
Like you just say build a website like Facebook, and a bot like creates like that would be cool.
That would be very cool.
That we can,
I think we need to walk before we can run.
what technically, like, what are the steps that you think are needed to make it at that level super easy?
Magic wand.
Magic wand. I think part of it is having, to me, and again, some would disagree with this approach, but having a lot of very smart objects. So having the system understand what a website is, right? Somebody needs to code that. How would you characterize a website like Facebook? So that's going to require categorization. So you say, website like Facebook has a bunch of users, and users are linked by friend for things, and then there's posts and messages, and effectively little mini blogs for people. So it's going to require a large, and this is where I was getting kind of in the marketplace, a large set of these concepts which have already been worked out that are designed to work together, right? And then the idea again is that you're, instead of creating all these things a priori, which is what we're doing when we're creating a new system, we're actually pulling these concepts in and matching them. So, what you're talking about, creating a website like Facebook, that is probably AI. I mean, that's again, that's not. I'm not trying to solve that problem right now, but it is a fine problem to solve. Yes, sir.
So I just want to say that I know of at least one programming language that actually lets you extend the syntax of the language dynamically, and that's Agda. Agda, A-G-D-A. And they have, they let you define what are called mix-fix operators, which are basically, they're not infix operators, they're not prefix or suffix. You could put arguments sort of in arbitrary places in the middle of a string.
Okay.
So you can have circumfix things, you could have things that's on the outside and also on the inside.
So mix fix because it's not a suffix or a prefix?
Yeah, it's mixtures of fixes, right? And you can define these on the fly. You just, you put an underscore where you want the arguments to go and it defines it. And so they had to develop a whole new kind of parser in order to handle that because, anytime you declare a name, you're declaring a new parse rule, basically. And it has to handle very strange things that, like most programming languages, don't actually handle. So there is some precedence for that, and they have good, efficient techniques for parsing that if you're interested in it.
Yeah, totally. I'm very excited. Yes, sir.
Well, I really appreciate this approach because when I am coding stuff, I am very much from the perspective of, and I do just static HTML sites, so I'm kind of the audience, right? Like I don't really code anything beyond, HTML and CSS. One of the frustrating things for me is, going in and writing some code and then like refreshing the HTML browser and trying to figure out like, okay, what changed and why did it change like that? And I feel like I get caught up in like making a small error, just duplicating the code. I'm like, oh, I want 2 more divs, and then I do that, and then it's like, oh, just like one small thing that I meant, like some syntax thing that breaks the whole thing. I'm like, So potentially the GUI would allow you to do those kind of things that are error prone really easily, but then when you do want to get in there and really like get with a little tiny wrench and tweak something, because that's one of the frustrating things about using pure WYSIWYGs like Wix or Weebly or any of those sites. It's like, oh, there's like one little thing and I can't fix it, and it's really frustrating. So,
The model I like is that the output of this is the same code that I would be writing as a JavaScript programmer, front-end programmer, and that I can go back and forth. Like it makes more sense to be copying and pasting the XML directly, or do that. It makes more sense to be holding down the option key and dragging the widget.
Yeah, because it's hard to make a system that's both, you know. It's hard to do a pure code language because then it's like a little hard, there's some disconnect between what you're seeing and what you're coding. But then if you're doing a pure, what you see is what you get, then you get things for it. It's exact. You know, so that's really interesting.
Yes, sir.
I just want to make sure, you probably know this, but in GitHub, if you're looking at the code, there's a lot of code that is real, that's actual code. And there's, I didn't see any examples, but that's just in case you were confused about like, because you asked like, it looks like it's still codes.
I think he was referring to the code for that card example.
Okay.
Yeah, because like it's the same thing. Like it's just a little bit easier, but I still have to write. Like computers are stupid. You have to tell them everything, and that's frustrating.
I
We've been
definitely
doing
agree.
that for like 30, 40 years.
Again, the goal is to get as many people as possible to be able to write this. And prior to that, to allow someone to read it and understand. Even if I couldn't write it, I can look at it and read it. And that's kind of the first step. Again, this is baby steps. Yes, sir.
So like, should you expect that actually like better apps will come out of this, or are you trying to get like everyone to be able to make an app? And then maybe like a better question is like, what would be your favorite project that would come out of this? You know?
The thing that I loved about HyperCard was people like Matt, who don't consider themselves programmers at all, that are massively creative, are able to get the computer and do something cool. That to me is kind of the end goal. And so it's more about the democratization of coding and kind of taking it away from the coders. And some coders I talked to about this are like, well, you're going to push out jobs, but again, there's always going to be coders writing the difficult bits, but the idea that someone from the business team could go and actually look at the business logic and tell you exactly what they want changed versus like give you imprecise, like, oh, no, wow. You know, that to me is a win. So, I could show, if there's a little more attention, I could show a little bit of that drag and drop environment that I mentioned. Yes?
Not related to what you just said, but what you just mentioned about like someone from the business team being able to say what they want to change. Have you considered kind of going the other direction and translating the code into more English? Because then if there is a team of programmers actually programming in pure JavaScript and then just showing the business team versus like having programmers who know how to write JavaScript learning something new that might not be as precise as what they're looking for.
In theory, the same system could be used to do that. I had not worked on that, but again, that pattern matching would work to match JavaScript just as well. The trick there is that if you're using a lower level language like JavaScript, you're not going to get the kind of popping things up semantically, so you're understanding why you're doing it. But that kind of, that kind of translation certainly should be possible. That would be interesting to experiment.
Like a way to say, like, maybe like looking at it and saying, translate this to the reader, you know, something I can understand, and then you can't actually change it, right? But you can at least comprehend. That's cool. That's good.
Okay, so this is another part of the same project which I was working on for a while, and then I got decided to just kind of pop out and work on English for a while. So the idea of this is that I am creating pages, taking a web metaphor, and what's actually happening is I'm parsing a React JSX file and allowing you. This is what is actually created. So basically, each of these things is an object, and I can select the objects. So I can select these objects. I can drag the objects around to drag them those one. So again, it's to it. And then after I have something selected here, I can modify its properties. Again, this UI is kind of primitive. But the output of this is those JSX structures that you would then populate with English. So you say, when the button is clicked, then you would use English to write that little button click. that make sense?
And do you, like, once you make it the categories, do you also see the code that writes the actual?
You can, yes. And again, it's writing. This is not using the English part yet. That's the next step with this one. But it is literally writing JSX. That's legal JavaScript. Yeah. And again, I'm trying to write exactly the same code I'd be writing if I was writing Python. And so, in addition to creating pages, you should be able to create components by assembling other widgets together and adding little pieces of glue. And that would get it added to that marketplace or that library where then you use that component somewhere else. So, yes, sir.
Can I give you my opinion? Okay. So I'm a JavaScript developer, so obviously I don't think JavaScript is that hard. And I'm just curious to know if like writing code or programming in more English syntax would decrease the expressive power you have in writing a program for that.
I don't necessarily think it would, especially if you had the ability to add new structures to do things that I didn't provide in my, as I've been thinking about it, what it actually allows you to do is think of things at a higher level. So to me, that's actually more expressive, because you're expressing intent rather than expressing the low level, oh, I got to write a dot map, blah, 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 blah. So part of this is, like, you can think of things like, libraries like underscore, that kind of stuff, where we're kind of using those as really adjuncts to the language. Those could all be built in as English syntax that then you can just apply to the code that you're writing. So there's an opportunity there, I think, to make it more expressive. And again, the way I'm structuring all this, if it's easier for you to write a JSX component directly rather than do this, go ahead and do it and just import it. And then you can use that component just like you can use a component you created in the system.
Could be.
Could be. Yeah. It's all experience.
It just depends on how many layers are out there, like how big the lexicon is, I guess.
And again, that's part of making the lexicon very easy too. Even easier for the end user who's not a JavaScript programmer.
And if there's a way for it to prompt you, like what you were talking about, the pop-up of like saying, well, did you mean this or this? Like in Star Trek, they say, like here, take the, the stellar data and parse it, put it in this chart, like it's presented here, and that's a lot of decisions are being made by the computer. But we could say like, well, how many rows do you want? Like, how wide, how big? I mean, that could help relieve some of that confusion. But I guess what you're talking about is like just the breadth of the capabilities, not necessarily like.
I haven't run into any concepts I could not express in that.
Okay.
So.
Because, writing the program is hard. There's a lot of things you have to do. You have to manage the flow of data, state the application, and then you need to connect with the back end, you gotta connect with the network, so all sorts of other things. So I don't know if I would prefer reading code or if I would prefer reading English. But that's just me. That's just my brain.
And you're not necessarily my target as the end user, but you may be someone who could extend the system for other people. If your thing is, using GraphQL, maybe making a GraphQL thing where other people could then use that as part of their that would be possible.
Yeah. You're gonna try to replace. Like, this is just another way of.
Again, this is another way of solving the same problem. But
Yeah.
Any other questions?
All right. Thank you for this fun presentation.
Thank you.